before going to start with the formation of the chemical bond, I just want to make you aware of the Lewis rules, because we need to use these rules while forming the bonds. So the first rule is that in the bond formation, only valence electrons are going to participate, right? Suppose I write a configuration for this thing sodium, you know that we need to write like this, or we can write the configuration like this for the sodium, we know that. So in both the cases, the outermost electron is 1, and even here the outermost electron is 1. So that means only the valence electrons, that means the valence shell electrons are going to participate in the bond formation. That means only the one electron is going to participate. The inner shells, they are actually well protected. The inner shell electrons are actually well protected and they don't participate in any kind of bond formation. Likewise, we need to represent these valence electrons, and how we represent these valence electrons, that means the electrons which are going to participate in the bond formation, they are represented by the dots or the crosses. Suppose if I say an atom has the one valence electron, you need to show in this way, right? If it has a 2 valence electron, you can show it this way. If it has a 3 valence electron, you can show in this way. If it has a 4, you can show in this way. 5 like this, 6 like this, 7 like this, and 8 you need to show in this way. By showing this, by making you know that how we are showing these electrons is just to make you aware that you don't need to distribute all the electrons like this, because some of the students, what they do, they just decorate the atom with the electrons. So no, it's wrong, right? You need to arrange the electrons in a specific order so that anybody who is just looking at your bond should be aware that how many electrons are actually participating in this bond. And you know that one more reason is that because by looking at these dots, you can just have the idea for the valence electrons. Like if I say that this atom has 2 dots, so it should strike your mind that how many valence electron it possesses. Obviously it has 2 electrons, because the number of dots actually represent the number of valence electrons. So this is what the rules which we need to follow. The first is that only the valence electrons are going to participate. Second is that inner shell electrons will remain unaffected, right? Third is that we need to show these valence electrons by putting dots or the crosses. Fourth, what information do we get from the valence electrons? We need to get to know that what is the valency or what are the number of the valence electrons. So by just looking at the dots, we can have an idea for that. So this is what is the Lewis rule. Now we are just going to use this rule and in order to show you that how we can form the bond. So likewise, we have 2 types of bond, as I told you, that the transfer of electron is the ionic bond, and the the sharing of electron is nothing but the covalent bond, right? So I'm just going to show you one ionic bond. Suppose I have sodium and chlorine. So if somebody asked me to form a bond between sodium and chlorine, how I'm going to form it? The first step is that I need to write their atomic number, right? So I've just written the atomic number for you. Second is that I need to write the configuration. Now the third step is that I just want to know that what valence electrons are going to participate. So here 1 is going to participate, here 7. And we know that the elements which have 1, 2, 3 valence electron, they are considered as metal, and which have 4, 5, 6, 7, they are considered as non-metals. And we also know that the bond strictly formed between metal and non-metal is ionic, because here one has an ability to donate an electron and other has an ability to gain an electron, right? So you are going to start with the metal one. So this is my metal. How many electrons? 1. Only 1 electron is going to participate. So what it is going to do, it is going to lose 1 electron, and after losing, it form a positively charged ion, right? Likewise, chlorine, it possesses 7 electrons. So I have drawn a 7 dots. It needs 1 electron to complete octet. So it accepts 1 and form the chloride ion. So what is my result? My result is that sodium with 1 electron, when combined with 7 electrons of the chlorine, it just forms sodium ion and the chloride ion. And when I crisscrossed, what do I get? I get NaCl. So this is my ionic bond. So this is the one method to represent an ionic bond. The other is that sodium and chlorine, I am going to draw the dots, and sodium has 1 dot. So here I am just going to put an arrow, and in order to show that which atom donates an electron and which atom gains an electron. And as you know that metal is going to donate, so I just write that this electron is given by this. So as a result, what do I have? I have this positive and I have this negative, again crisscross, and I get NSC. But according to me, you know that this method is the best one to show the bond formation, because here you get a full detail actually, right? One more example I want to show you in order to make you understand one more concept. Suppose I told you to make a bond between aluminium and oxygen. So I am going to write the atomic number, I am going to write the configuration, you all know how to do that. Now aluminium has 3 electrons. So how many electrons the aluminium has to lose? Obviously it has to lose 3 electrons. So this is what I am losing, making it lose 3 electrons, and after losing it acquires 3 positive, because the number of electrons an atom lose, it is equal to the positive charge it gets, right. Now oxygen, it has 6 electrons, it is going to get 2 electrons and it is forming O2 negative. So what result I have here? Aluminium initially with 3 electrons, oxygen initially with 6 electrons is forming Al3 positive and O2 negative. After doing crisscross, what do I get? I get Al2O3. So that means in this case 2 aluminium is combining with 3 oxygen. So I am not going to disturb these 2 steps, I am just going to put here 2 aluminium and 3 oxygen. Right. So by doing so, we just get a clear idea that 6 electrons are donated by 2 aluminium, and likewise 3 oxygen are taking that 6 electrons, and after that we have achieved a stable bond of Al2O3. So this is how you need to make a ionic bond. But when we talk about covalent, so in covalent bond what we have to show? We have to show a sharing of electrons. Suppose I say that this is I want to make a chlorine molecule. So we know that in chlorine molecule, one chlorine combines with another chlorine, and they are just deprived of 1 electron. They have 7 electrons. So this is what I am showing here. Again for this also it is the same thing. So as they are deprived of only 1 electron, they need to share only 1 electron. So you are going to put that electron in mid of them, right? So what is there? These 7 electrons, and it is sharing this 1 electron. Again it has a 7 electron, it is sharing 1 electron. So as a result they get a single bond between them. So this is a bond which is formed between Cl2, that is by the mutual sharing of electrons. Likewise we get to see in this thing CH4 as well. So in this as you can see there are 5 atoms. So that means the one which has more electronegative is going to occupy a central position. So here is my C. I will surround it with 4 hydrogens. As we know that carbon has 6 electrons and hydrogen has 1. So configuration 2,4 again 1. So that means hydrogen has only 1 electron, and as we know that for to attain stability they need only 1 electron, because they actually have a duplet structure. That means tendency to attain 2 electrons in outermost shell, because when they will gain 1 electron, 1 is already there, 1 they will gain, and their first shell will have 2 electrons, and we know that the first shell gets stable when an atom has 2 electrons, right. So this carbon has 4 now, and it has to arrange these 4 electrons in such a way that each hydrogen gets the same electron. So it is just arranging in this manner. So what happens? This hydrogen gets stable, this gets stable, this gets stable, this gets stable. So all 4 hydrogens get stable, and likewise this share all electrons and it forms a stable covalent bond, that is with a single bond. So this is how you are going to make the covalent bond, just by showing the mutual sharing, and here you need to show that one has already, like one is just making its electron go, right, and the other is just accepting that electron. So this is what is the ionic bond, that is the transfer of electron, and the mutual sharing is the covalent bond. We will be just now starting with a few more examples. I will just make you well versed that how you need to make an ionic bond or the covalent bond. Keep looking at the board, because I am just going to explain you with many more examples.